For real numbers a and b with a greater than or equal to 0 and b greater than or equal to 0, the operation symbol is defined by a symbol b is equal to the root of a plus 4b. For example, 5 symbol 1 is the root of 5 plus 4 times 1, which is root 9, which equals 3. What is the value of 8 symbol 7? So according to this, we will do 8 symbol 7 as follows. It will be the root of 8 plus 4 times 7. And that is 8 plus 28, which is root 36, and that is 6. Part B, if 16 symbol n is 10, what is n? Okay, according to this definition again, 16 symbol n would basically be the root of 16 plus 4n, and they're saying that's equal to 10. So then square both sides, and you get 16 plus 4n is equal to 100, and therefore 4n is equal to 84, and divide through by 4, and you get n equal to 21. Part C, determine the value of this thing here. All right. So 9 symbol 18, and then that answer will then be used to work with 10. Okay, so first let's do this one. So according to the definition, that's going to be 9 plus 4 times 18, and that's symbol 10. So this is what, 72 plus 9, which is 81. So root 81. And then root 81, of course, is 9. So then we have 9 symbol 10. So according to the definition, that is the square root of 9 plus 4 times 10. And I believe that's root 49, which of course is equal to 7. With justification, determine all possible values of k such that k symbol k is equal to k. All right. So again, going back to the basic definition, that would be the square root of k plus 4 times k is equal to k. Square both sides, and we get, well, this is 5k, so it would just be 5k, and this would be k squared, I believe. Put everything on one side, and you get k squared minus 5k is equal to 0. Factor out the k, and we get k and k minus 5. So that means either k is equal to 0 or k is equal to 5. Each week, the Math Tunes Music store releases a list of 200 songs. New song Recursive Case is released in time to make it onto week 1. The song's position, P, on the list in a certain week, W, is given by the equation P is equal to 3W squared minus 36W plus 110. The week number W is always a positive integer. What position does the song have on week 1? So when we have week 1, we are basically substituting W for 1, I believe. And I think that's it. So just put W is equal to 1 and solve this. And when you do this math, this is what, 3 minus 36 plus 110, which I believe is 77. So that means that on week 1, the song will be on position 77. Part B, artists want their song to reach the best position possible. The closer that the position of a song is to position number 1, the better the position. What is the best position that the song Recursive Case reaches, and on what week does this song reach the best position? Okay, so I guess we're using that equation again. So it's P is equal to 3W squared minus 36W plus 110. Okay. Let's think about this for a second. All right, so I think that this is a parabola, obviously. I don't know what it looks like, but usually there's something like this, right? And this has a positive value before the W squared, so that means it's pointing upwards. Now, we know that there's an absolute bottom value for some value of, I guess the variables here are W and P, right? So for some value of W, we're going to hit the absolute rock bottom value for P. And that's what they want. They want the lowest value for P because the smallest number indicates the best position, right? So, for example, if the smallest position was 7, that means it's number 7 on the chart, which is pretty decent, right? It's close to number 1. Okay, so how do we do that? How do we find this point? Well, I think you just complete the square. You guys know how to do that, right? Complete the square. And when you do that, you find the vertex. You find this vertex. And it'll be of the form HK. And then that's it. So let me complete the square and show you. So I first factor out that 3, and that will give you w squared minus, oh, there should be a w here, sorry. Minus 12w, and then put the 110 out here. And then from there, we have to take half of this guy and square it. So half of minus 12 is minus 6, and square that. So that's going to give you plus 36. But then you have to immediately subtract 36 because you can't just add something to an equation. And then now these 3 guys factor very nicely. It'll be w minus 6 all squared. And then don't forget that this guy has to kick this guy out. So 3 times minus 36, I believe, is minus 108. And then don't forget that 110. And then in its final form, it's just w minus 6 squared with the 3 out front. And I think this is plus 2. So this now gives us our vertex. Remember, x minus h squared plus k. This is the standard form where the vertex is hk. So in our case, our vertex looks like 6, 2? No, hold on. Yeah, 6, 2. So I guess my graph was a little wrong since this is positive. But that's okay. It basically means that when w is equal to 6, p will be equal to 2. So on week 6, the position will be the lowest. And in this case, that position is 2, number 2 on the chart. What is the last week that recursive case appears in the top 200? Okay, so recall that the position is calculated by this formula, and we want it to be in the top 200. So we want this position to be less than or equal to 200, because if it's greater than 200, then it's no longer in the top 200. Like if it was 201, then it's no longer listed in that top 200 list. So we want this p to be less than or equal to 200. Okay, so let's just work with that. So that means this equation now becomes 3w squared minus 36w minus 90 is less than or equal to 0 if you bring the 200 over. So what I'm going to do is, again, I'm not sure what this looks like, but if I were to graph it, this is positive, so it's going to point upwards. And we want it to be less than 0. So that means that we want, what do we want? We want this segment of the graph. So we will have to find this point and this point. And since w has to be an integer, is the element of integers, we will see what is the largest integer before that point. Maybe that point is an integer, but I guess we have to find out. Okay, so how do we do that? I think we just, I don't know if I can complete, this is not a complete the square situation. This is just a quadratic, so I'm just going to use the quadratic formula. And on the Canadian exams, you're allowed to use a calculator, so that's good. So I'm just going to set it equal to 0 and just use the quadratic formula. First thing, of course, is just divide through by 3, make it a little bit easier. And I don't think this factors, so I'm going to have to use that quadratic. So it's minus b plus or minus the square root of b squared minus 4ac all over 2a. And then when you crunch out these numbers, I'll let you guys do that. You get 2. You get minus 2.1, and you get 14.1. So obviously, well, my graph is surprisingly accurate this time. Last time it wasn't, but that's okay. This is the minus 2.1, and this is 14.1. So we want, and this is W and this is P. So we want basically the largest value of W that's an integer. Well, to me it looks like that would be W equals 14. And basically what that means is that in the 14th week, it's the last time that the P will be less than 200, the position of the song. A pyramid ABCDE has a square base ABCD of side length 20. Vertex E lies on the line perpendicular to the base that passes through F. The center of the base ABCD. It is given that EA is equal to EB is equal to EC is equal to ED is equal to 18. Determine the surface area of the pyramid ABCDE, including the base. All right. So the first is the base. The base is just a square, so that surface area is pretty straightforward. That's just 20 by 20, so that's 400. And then we have 4 of these triangles, and these triangles I think are all the same, and they're all isosceles, so the 18, 18, and 20. So that's, if I draw a perpendicular, chop that into half, 10 and 10, and then this is the height. I can use Pythagoras to figure out that height. So it's going to be 8 squared plus 10 squared is equal to 18 squared. And that means h is going to be root 224. So the area of this triangle is 1/2 base times height. The base is 20 and the height is root 224. So that's 10 times root 224. Yeah. Okay. So the total surface area is the total surface area will be the base, which is 400, and then 4 of those triangles. So 4 times this 10 224, and that's going to be 400 plus 40 times root 224. What's root 224? Is it 4 root 14? I think 4 root 14. I think so. So that's 400 plus 160 root 14. And that's about as far as you go there. Okay. Determine the height EF of the pyramid. All right. EF. Okay, let's do it. I'm going to need some space here. All right. So the EF, what I'm going to do is, I think I will draw. Let me draw 2 lines, and then I'll explain what I'm doing here. But let me use a different color. So the first line I'm going to draw is from F all the way to that side. Yeah. And the next line, of course, is from E all the way down to that point that it touches. Okay, that's good enough. Okay, so now what I'm going to do is draw that triangle sort of over here, because I don't want to make the diagram too messy. So the same triangle that I drew, I'm just drawing it here. So this is E, and this is F, and well, whatever this you want to call this, whatever, M, I guess, M for midpoint, let's say. F to M, that's half of 20, so that's going to be 10. That's pretty straightforward. This is a right angle. EF, I think, is what we're trying to figure out here. And EM, that's interesting because that is something we've already figured out right here. It's H. And we already figured out what H was. It's root 224. So that helps tremendously. And now this is just Pythagoras. So we have EF squared plus 10 squared is equal to 224 root all squared. Okay, so that's EF squared is equal to 224 minus 100. And that's just 124. So EF, if you take the square root, would be root 124. And in a mixed radical, that's 2 root 31. And that takes care of that. G and H are the midpoints of E and ED and EA. respectively, determine the area of the quadrilateral BCGH. BCGH. Okay, so first, of course, I have to attempt to draw a connection between G and H. So G is the midpoint of ED, and H is the midpoint of EA. So something like this. That's pretty decent. And then I'm going to connect them because we're trying to form a quadrilateral, right? BCGH. So I guess C is going to connect to this guy here, and then that other point is going to connect down to B. Okay, so there we go. So that is basically the quadrilateral that we have to figure out. And I'm going to draw it sort of over here like a flat, like that. So this is my C, this is my B, and what were the other ones? G and H, right? Okay, so I'm pretty sure this is a trapezoid, if I remember my shapes. And this BC, that's easy, that's 20. HG is 10, because G and H are the midpoints. So since they're the midpoints, they're going to basically be halfway up from DA. So in case you're not convinced of that, let me just draw that triangle, D, A, and E, like that. So G and H are the midpoints, right? So here's G and here's H. Now DA, we know that's 20. Now since their G and H are midpoints, they're halfway up. So since they're halfway up, the G to H is going to be half of DA. That's just this basic, property. Okay, so we're pretty close to getting this, actually. Already we have a lot, but of course we need that altitude in order to figure out the area of that quadrilateral. So that's our next step. Okay, so how do we do that? Okay, so the first thing is when I draw this is going to be 10, so that means this is 5 and 5, and this I'll just call H for now. And then GC, I think, is my next step, this side right here. I think that's the next step that I'm going to concentrate on. All right. And I think the way to do that is trigonometry. I'm pretty sure. Yeah. So what I will do is I will draw one of the triangles, and I'll explain it from there. So let's draw one of these triangles here. Now, which triangle am I drawing here? I'm drawing C, D, and E. And let's label this accurately. So C to D, that's the base, so that's 20. And then ED and EC, those are 18, right? Okay. So what I'm interested in is actually these angles. I'm going to need these angles. So since this is isosceles, let's just draw that. So that makes it a perpendicular. And then this angle in here, I'll just call theta. And that means this is 10 and this is 10. And that line I just drew from E, I think I already figured that out. I think that was root 224. Yeah. Okay, so that's good. Now I can figure out this. So that means that the sine of theta is root 224 over 10. Oh, is it? Oh, wait, over 18. Oh, make sure I don't make that mistake. Okay, so that's good because now I can use my calculator to figure out theta. And when I do, I get theta is equal to 56.25 approximately. Okay, so that's really helpful because that allows me now to figure out that angle. I just subtract it from 90 since this is already 90. And when I do, I get 33.75. All right, great. So let me just draw this again because I don't want to make it too messy. Same triangle, D, E, and C. Now, since this angle is also going to be 33.75, that means that this full angle is 67.5, approximately. I don't think it's exactly 67.5, but yeah. Or maybe it is. I actually don't remember if that was exact or approximate, but whatever. We'll get pretty close. Or you can just save it. Whatever this is, just save it and then use it later. And then you'll get the absolute exact value. Okay, so now what we are trying to figure out, CG. What is CG on this triangle right here? Well, I'll show you. CG, G is here. Remember, G is the midpoint of DE. G is the midpoint of ED. ED is the same thing, so this is G. So CG is basically a line from C to G. And the good news is, we know that DE is what? 18. So since G is the midpoint, this will be 9 and 9. And CE, that we know is 18. And then now we've got this little triangle. We have two sides and an angle, and that screams cosine law. And I think that pretty much would do the trick. That would allow us to figure out GC. Then once we get GC, we put GC there. Then with Pythagoras, we'll get H, and then we can figure out the area of that shape. Okay, so here we go. Cosine law. Let's see here. Cosine law. So CG squared is equal to 9 squared plus 18 squared minus 2 times 9 times 18 cos whatever that angle was. I'll let you crunch out these numbers. And when you do, you get exactly equal to 281. So that's great. It's a nice round number. There's no decimal points. And then therefore CG is the root of 281. All right, so this here is root 281. All right, now we just use Pythagoras on that triangle. So that means 5 squared plus 8 squared is equal to 281 root all squared. This will give me, when I crunch out these numbers, H equal to 16. And now my final step is to figure out the area of that shape. And I believe that shape is a trapezoid. And the area of a trapezoid is, you take the base and you add it to the top, and then you divide by 2, and then you multiply by the height. So that looks to me like 15, and then H is 16. So 15 times 16, I believe, is 240. Yeah, and there you go. So not so bad. It's actually a pretty decent question. The triple of positive integers x, y, z is called an almost Pythagorean triple, or APT, if x is greater than 1, y is greater than 1, and x squared plus y squared is equal to z squared plus 1. For example, 557 is an APT. Determine the value of y and z so that 4yz is an APT. If this is true, then that means this is true. So that would be the 4 squared plus y squared is equal to z squared plus 1. Now rearranging this gives me z squared minus y squared is equal to 15. So we have to find two perfect squares that differ by 15. Okay, let's see. Let's list all the perfect squares here. 1, 4, which is 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared. I already see it. 9 squared is what, 81. Okay, I already see it. So the difference between these two is 3. The difference here is 5. The difference here is 7. The difference here is 9, 11, 13, and this one, 15. These are two perfect squares that have a difference of 15, which is exactly what that is. So that means that z is 8 and y is 7, right? Z is 8, y is 7. Yeah, so that pretty much solves that. So that means that is 4, 7, and 8, this APT that they are describing. Prove that for any triangle whose side lengths form an APT, the area of the triangle is not an integer. If we use trigonometry, the area of a triangle can be used as 1/2 AB sine C. So for example, if you have a triangle like that, and this is A, and this is B, and this is C, this angle. The area is AB sine C. So we're going to use that eventually. And then, of course, we also need to use cosine law in this question. And the cosine law, in particular, again, on this if this is side C, on this triangle would be C squared is equal to A squared plus B squared minus 2AB cos of that triangle C. Angle C. And then let's not forget this very important property that I think somewhere, somehow we will use in this question. All right, so let's keep going. The first thing I'm going to do is isolate this guy here for cos C, because eventually I'm going to have to put sine C in there to figure out the area. So let's just figure out what we get for cos C. When I isolate for cos C in this guy, that's going to give me A squared plus B squared minus C squared all over 2AB, I believe. Yeah. Okay, now this property comes into play. In our case, our letters are A, B, and C. Well, I made them A, B, and C. So if I use the same letters A, B, and C, since this triangle has sides that form an APT, then that means that A squared plus B squared is equal to C squared plus 1. So that means that A squared plus B squared minus C squared is equal to 1. So this guy in the numerator is exactly what this is. So that means it's equal to 1. So I just put that there. And that very nicely gives me the cos C is equal to is equal to 1 over 2AB. Okay, we're getting somewhere, I think. Now, but I need sine C. I don't need cos C, right? So somehow I have to figure out sine C. But I know a very nice property that most of you know, probably the most famous trig property, is that the sine squared of something plus the cos squared of that something is equal to 1. So I can use that to figure out sine of C. So if I put this on the other side, it'll be like this. And then cos C is 1 over 2AB. So that's going to be 1 minus 1 over 2AB all squared. And yeah, that's pretty good so far. Okay, so now let's finally look at the area. The area is AB sine C over 2. But there's a little bit of a difference here. This is sine squared C, and I just have sine. So what I'm going to do is square both sides. And that gives me A squared B squared sine squared C over 4, right? Yeah. And now I'm going to make the substitution for this guy. So that means A squared, let me just separate this, A squared B squared over 4. And then the sine squared C is this 1 minus 1 over 2AB all squared. Yeah. Okay. And then I will expand, and let's see what I get when I expand. I get A squared B squared over 4. And then when I multiply the other guy, I think I'm going to get, I think the A squared B squares are going to cancel. And it's going to be 4 on the denominator, so it's going to be 1 over 16, I believe. Yeah. Okay, that's pretty good. Now what do? Multiply through by 16 to get rid of these fractions. So 16A squared is equal to 4A squared B squared minus 1. And then put the 1 on the other side, and I'll just be left with 4A squared B squared minus 16A squared, I think. And then factor out a 4. And then finally I have A squared B squared minus 4A squared. Okay, I think this is about as far as I can go. Now, what were we trying to prove? We were trying to prove something, right? What were we trying to prove? The area is not an integer, the area of that triangle. Okay, so we had called our area A. So we have to show that A is not an integer. Okay. All right, so I guess the heart of that comes from this equation. All right, well, this side is 1, which is an odd number. And this side here, because it's a multiple of 4, it's an even. Yeah. So obviously, even on one side, odd on one side, that doesn't work. The only way that this could work out is if there was some fractions in here. Yeah. Are the sides integers? Yeah, well, the side lengths form an APT, and an APT are integers, right? Yeah, positive integers. So we know that A, B, and C are integers. Okay, I got it. So since A and B are integers, that we know from the whole definition of the APT, for left side to equal right side, A must be a fraction or decimal. Yeah, because if A is an integer, there's no way that this right side will equal the left side. So therefore, A is not an integer. Yeah. I think that's about as far as I can take this. I mean, maybe you can explain it a little bit better in terms of your sentences. You know, that's sort of the part of the question that doesn't involve numbers anymore. You sort of have to explain it in words. But whatever, I think that's pretty good for this question. Determine two 5-tuples BC PQR of positive integers with p greater than or equal to 100, for which 5t plus p, bt plus q, and ct plus r is an APT for all positive integers t. All right, well, if from the definition of an APT, remember if it's a, b, c, it would be a squared plus b squared is equal to c squared plus 1. The basic definition of the APT. So according to that, 5t plus p squared plus bt plus q squared is equal to ct plus r squared plus 1. Right. Okay, so let's expand this. 25t squared plus 10pt plus p squared, and that is going to be added to b squared t squared plus 2bqt plus q squared is equal to c squared t squared plus 2crt plus r squared plus 1. Okay. So put everything on one side and collect like terms and do a little bit of factoring, and I get 25 plus b squared factored in front of t squared, and then 10p plus 2bqt, and then plus p squared t squared, p squared q squared, and then on the other side I have the c squared in front of the t squared, plus I have this 2cr in front of the t, and then I have this r squared plus 1. Okay. All right, so that means that some of these things have to match. So this guy, this coefficient right here, has to match this guy, I believe. And then this will be the same as that, and this will be the same as that. So that means that 25 plus b squared has to be the same as c squared, the coefficients. That'll be equation 1. Equation 2, 10p plus 2bq is going to be the same as 2cr. Call that equation 2. And then finally, p squared plus q squared is going to be the same as r squared plus 1. And we call that equation 3. Okay. Now, first let's talk about this guy here. That one looks like a Pythagorean relationship to me. I can think of one immediately. Very famous one, 5, 12, 13. Right? Because 5 squared plus 12 squared is equal to 13 squared. So that means that B will be 12 and C will be 13. Yeah. Okay, so that's very helpful, actually. That allows me to get two of these values very quickly just by identifying them as Pythagorean. Then I'll substitute those two values, B equals 12, C equals 13, into those two. And when I do, my equations now become 10p plus 24q is equal to 26r. And this guy becomes 5. Hold on. Well, let me just simplify this. I think I can divide through by 2 here. 12q is equal to 13r. Okay, so we'll call that equation 4. And then now, what can I do now? P squared plus q squared. At this point, there's nothing to substitute here, so because there's no B or C. But I have to somehow work with this guy and this guy. Those are the only two equations left. All right. And then, of course, knowing that B is 12 and C is 13. I think I can make it look similar by squaring that. If I square that, I'll get 25p squared plus 120pq plus 144q squared is what, 169r squared? Yeah. Yeah, and then I can call that equation 5. And then what? I think at this point I could probably use this guy since I've got p squareds and q squareds. But first I think I might have to... okay, I'm going to try to at least reduce it to 2 variables because I currently have 3 variables. I have p, q, and r. So let me isolate for r. It's going to be p squared plus q squared minus 1 is equal to r squared. And then I'll put that into here. Okay. All right, so 25p squared plus 120pq plus 144q squared is equal to 169, and then this p squared plus q squared minus 1. Okay. All right, I think that's pretty good. All right, so let's expand this out and collect like terms and all that stuff. And when you do, you get 144p squared minus 120pq plus 25q squared is equal to 169. And then this factors very nicely, which is wonderful. 12p minus 5q all squared is equal to 169. So that basically means that 12p minus 5q is equal to plus or minus 13. Yeah. Okay, so at this point, we have only one equation and 2 variables, so now we have to sort of use trial and error to figure out values of p and q. So this explanation I have just pasted goes through how you would actually come up with values of p and q, and I will let you read it and go through it. And it's basically an analysis of the units digits to come up with values for p and q. And when you finally do, you come up with a couple. One solution is when p is 101 and q is 245. And the other solution is when p is 104 and q is 247. Those are the two that solve that. And this is how it's done. And I will let you read that. Well, now it's easy. Now that I have p and q, you can just get r from here. Where is that equation? Yeah, just plug p and q into that to get r. And then b and c, well, those are 12 and 13. So we already know that. So b and c, those are just 12 and 13. So that's always going to be 12, and that's going to be 13 over here. And then when you use that equation upstairs to figure out R, this gives you 265, and this one gives you 268. So our 5 tuples, B, C, P, Q, and R. The first one is 12, 13, 101, 245, and 265. That's this guy. And the next one is 12, 13, 104, 247, and 268. And that is this one right there.